All right, so section P7. Solving absolute value and polynomial inequalities. I'll tell you that the absolute value inequalities, not super important to your future mathematics careers. However, polynomial inequalities, big deal going forward. We'll use them a lot this year, and they're going to be pretty big deal in calculus as well. So I'll make sure, hopefully, that you're very good at polynomial inequalities. So start off with some basic algebra 1 stuff, solving absolute value inequality. Remember what we talked about last week? You shouldn't be solving any absolute value things until the absolute value bars are alone. Make sure you get that structure alone first. This one is alone. Once your absolute value structure is alone, you should set up your positive case and your negative case. For your positive case, you pretend there's no bars. Now for the negative case, like I said, you were probably told to just make this number negative and then drop the bars and go from there. The problem is when you get to inequalities, when you make this number negative, you also have to remember to flip this inequality over, and I find that students will often forget to flip that inequality over when they make this negative. So the way that I combat that is I say, instead of switching this sign on the right side, change all the signs on the things that are in the absolute value bars. It's the same result, but students are more likely to remember that they need to turn the inequality symbol over when they're forced to divide by a negative number. If you don't want to do it that way, it's fine with me. I just want to make sure that everybody's cool with it. Going to add 4 to both sides here. Real simple. So x is less than 12. And this one over here, subtract 4 from both sides. And here it is. When you divide by -1, that will force this inequality symbol to flip over. So it gives us x is greater than 4. Now, that's you know, fine. What? I got you. I see. So right there, 8 minus 4 is positive 4. Negative 4. Good catch. You saved the YouTube video. Anyway, because I can't edit it. I don't know how. Okay, anyway. So solving for these x values, this is, like I said, algebra 1, maybe algebra 2. But what's really important to me is that you actually understand what this means. It's not enough to go, yep, those are the answers, if they don't mean anything to you. And it is an algebra 1 and algebra 2 standard that students understand that the solutions to equations and, you know, inequalities as well are points in space. You're supposed to be able to relate it to the graph. So I have Desmos fired up for us, and I would like to show you exactly what these answers mean. So we're going to graph absolute value x minus 4, absolute value. Where's my other? There it is. So there's the graph of x minus 4. Ooh, it's black. I don't like that. Let's make it blue. There we go. And the other one is a horizontal line, y equals 8. I would like you to see that parts of the blue graph are above the line y equals 8, and parts of the blue graph are below the line y equals 8. They intersect each other at those two coordinates. Our question specifically says, when is the absolute value less than 8? As far as the graph is concerned, that means when is the V-shaped graph actually below this y value? And so it's this whole zone here. All the y values here are still positive, but they are less than 8. And that's what we were hunting for, is all the places where our y values would have been less than 8. So the answers have to be between -4 and +12. Now that is an overlapping set. I'm going to write the answer this one time as inequality, but from here on out, it's going to be interval notation. This is overlapping because there are numbers that are bigger than -4 and smaller than 12 at the same time. So you can say -4 is less than x is less than 12. On the test, though, that answer set would have been in interval notation, like this. This is not the coordinate -4, 12. This is the span of x values from x equals -4 to x equals 12, not including -4, not including 12. What this means is if you take any x value between these two x's, and you drop it right there, this graph's y values would be less than 8. That's what that means. So it should always be relating back to the picture of the graph. Now I'd like to introduce a concept to you that's called graph theory. And graph theory is really almost shortcuts to things. This is a V-shaped graph, and I hope that your knowledge of transformations tells you that that V-shaped graph points up because there is a positive number in the front of the absolute value bars. It's a 1. But because it's positive, it points up. If it had a negative sign outside the absolute value bars, it would have pointed down. But what I'm getting at here is, regardless of where this graph is, it would have pointed up. And the assumption is that the horizontal line, y equals 8, would have intersected it somewhere. This is not the x-axis, this is the line y equals 8. Because it says less than, I automatically knew that I was looking for this zone, from this x to this x. Not outside of the zone, not the numbers to the left of this, not the numbers to the right of this, but specifically between them, because that's where a V-shaped graph that points up would have been below it. Okay? You don't have to know this, you don't have to do this, but it would be great if you understood it, because it gets you to, not to the answers faster, but it helps you eliminate bad answers faster. You would automatically know, oh, it's got to be a span between two numbers, not outside two numbers. That would help you eliminate probably half the wrong answers, I'd say. Questions on that one? Pretty simple? Okay. Let's do it again. We start with the graph theory this time. Again, my absolute value bars are alone, so I could immediately jump to the algebra. But this absolute value bar has a positive number on the front. Once again, it's a 1. But because it's positive, I know that V-shaped graph points up. Now there's a horizontal line, y equals 5, somewhere. Picture not drawn to scale. I'm making the assumption that it is going to intersect twice. There's the line y equals 5. Now if it does intersect twice, I'm looking for y values that are specifically bigger than that horizontal line. So that would mean all of these numbers going that way, and I put a bracket there specifically because of the equal to bar, and all of these numbers going that way. Again, bracket because equal to bar. Just knowing this tells me any answer that looks like this, that spans between two x's, is instantly garbage. It's just a shortcut. It tells me I know I'm going to be looking for numbers to the left of something and numbers to the right of something that never overlap, if it actually intersects. Let's go ahead and solve. Go to the algebra, everybody's favorite. Yeah, solve for x, right? Positive case, drop the bars. And negative case, I'm going to switch the signs on the inside of the bars. You can choose to switch the sign on the 5. Just remember, if you switch the sign on the 5, you'd better turn your inequality symbol over. My years as an Algebra 1 teacher tell me, people forget that step. It's there. Solve them both for x. Subtract 2 from both sides over here. And then divide by -1. Oh, the positive case this time actually has us dividing by -1. Telling me that my answers are x is less than or equal to -3. To the left of a number. Because I already knew that the graph should look something like this. If I made another mistake, I changed what? Oh my gosh, is that the same mistake I made last time? No, I made that mistake in first period. The exact same mistake. Crap. There we go. I get so hung up on what the answer is going to be. No, I know it's -1. There we go. I get so hung up on the graph theory that I forget to check my math. This answer makes sense to us because it says to the left of a number. So that would tell me that more than likely this line is at x equals -1 on the left side. Now let's go ahead and solve the positive case. Add 2 to both sides. Gets 3x greater than or equal to 7, and then divide both sides by 3. Greater than or equal to 7/3. That might not be the prettiest of fractions, but it does jive with what I thought this picture would do. Numbers to the left and numbers to the right that never overlap. So it works out perfectly for what I thought should happen. They don't overlap. So what's that answer set look like in interval notation? Well, it never stops going to the left. So that crashes all the way down to -infinity. So we're going to say from -infinity up to and including the number -1. So we put a bracket on it because it's included. Then a U for union. Numbers beginning at 7/3, including 7/3, so bracket. But never stopping as we go to the right, so all the way out to positive infinity. That is the answer to this absolute value question. Again, I'm going to throw it on Desmos in just a second, once everybody's written it down, just to really drive home the idea. Yes, ma'am? Mm-hmm. So the reason why is because for the first one, my answer set actually fell between the green lines. So I could actually list this as from here to here, which is one set. However, this is everything that's not in between. So everything over here and everything over here. Because they have absolutely nothing in common, I don't have the ability to say, my answer is a number that is greater than -4 and less than 12. I can't say a number less than -1 and greater than 7/3. That makes no sense. So we have to separate them with a union. Is that better? It's because they don't overlap. They have nothing in common. Yes?
So why wouldn't you switch the inequality sign?
So because I didn't change this number, I didn't have to switch this sign. If you had written 2 minus 3x over here, then you would have needed to set less than or equal to -5. You would have subtracted your 2. So now you would have had -7 over here. And you would have divided by a -3, which would have flipped your inequality over to give you a greater than. So it still works. It's just that when I taught Algebra 1, I saw a lot of times when the students put a -5 here, they forgot to flip this over because they were just so used to changing the number. So I just decided to start teaching, switch everything on the inside, because when you're forced to divide by a negative, you just remember. Now Desmos, just so you can see what it looks like, what I have, 2 minus 3x, and y equals 5. And we were specifically trying to figure out when the V-shaped graph was greater than, which as far as the graph is concerned, that means above the horizontal line. So it was everything to the left of x equals -1 and everything to the right of x equals 7/3. That's where my V-shaped graph sits above the line y equals 5. We comfortable with all that? Did you know that Desmos does this? But it doesn't look like a V-shaped graph anymore, does it? But you'll notice it's the same answers. It's shaded everything to the left of -1 and to the right of 7/3. I don't like that. I prefer to think of it as y equals. So they're both y equals. Y equals this, y equals this. Where do they cross? And where's one above the other? It's a really important concept when we get into calculus. Polynomial inequalities is the first or second most missed question on the chapter test. Yes, is it about the previous question?
It's like about all of it, kind of.
Okay.
Did I have to like put them on a number line?
No. No, we're never going to put them on a number line. That's elementary. But if you think about it, we did. Desmos, just a second ago, put them on a number line when it shaded all to the left and all to the right. That was the number line if the only thing you saw was the x-axis. But no, we're not going to do that. So yeah, this skill, first or second most missed question on the chapter P test. If it is said equals 0, let's just pretend it says equals 0, how would we have solved? Yeah, factoring should be your go-to method. So here's what we're going to think. We're going to think it says x squared minus x minus 30 equals 0. It doesn't, but that's how we're going to treat it for now. We'd be looking for the two numbers that multiply to negative 30, that add to negative 1. And I would hope that those numbers jump out to everyone. Positive 5 and negative 6, good. So if x plus 5.
It's positive 6, negative 5, positive 1. Positive 9.
Goodness.
What's up today?
I don't know.
Watch Minecraft again?
Boop, fixed. Ta-da. Like that. Now remember, it doesn't say equals 0. That's just what we're dealing with right now. Now that it's factored, we could see the solutions to this quadratic. But here's our problem. The question didn't say, where does this quadratic equal 0? What it said was, when is this quadratic less than 0? So what do? Do you say x is less than negative 6 and x is less than 5? Well, no, that doesn't make any sense. Because all the numbers that are less than negative 6 are less than 5. So why would you say that? Also, you just said numbers less than 5 work. Well, let's see if we plug in a 4, what do we get? 16 plus 4 is 20, and 20 minus 30 is negative. Okay, cool. Yeah, that happened to work. How about numbers less than negative 6, like negative 7? 49 minus 37 is not less than 0. So clearly we can't just let this symbol be a less than symbol. So what do? Two options. Option number 1, just understand your graph theory. This is a quadratic. Does it point up or down? Up. The number in front of x squared happens to be positive. That means this parabola points up. Do some orange and blue, go Gators. And we just found out that this quadratic does have solutions. That means it does cross the x-axis. This is the line y equals 0, also known as the x-axis. We were specifically supposed to find the places where our quadratic was less than 0. So where did our quadratic give us negative y values? It did it between the two solutions. Because that's where we have negative y values, and negative numbers are less than 0. But your go-to method, because there's a good chance that not everybody is deeply understanding what I'm talking about when I say graph theory, is to use something called a sign diagram. And you will use them a lot in calculus. A lot. A sign diagram represents the x-axis. And what you put on this x-axis are what we call critical values. Critical values are where your polynomial equals 0 or is undefined. The polynomial is never undefined. So we only have two x values on this sign diagram, that's negative 6 and positive 5. These are representative of x values on the x-axis. A sign diagram checks for whether or not the y values would have been positive or negative without actually caring what the value was. We just know it was positive or we know it was negative. Because that's all we need to know, specifically when is it negative. So what you have to do is you have to take a representative number from each of the three zones. For example, -7. I already said this one. We take -7, we drop it here and here. Now, I don't care what the number is actually going to be. All I care about is whether or not it's positive or negative. -7 plus 6 is negative. -7 minus 5 is negative. So when you multiply these two negative numbers, what kind of number do you get? Positive. What that just told me is that everywhere to the left of x equals -6, my y values are all going to be positive. That's what this says. Everywhere to the left of x equals -6, y values are positive. Grab a representative from this zone. It's my favorite representative to use because it's so easy. 0. 0 is our friend. Just pretend there was no x's. Oh, that's definitely going to give me a negative number. What that tells me, go home, negative sign, you're drunk. What that tells me is every single y value between these two x's will be a negative y value. I don't know what those numbers actually are, I just know they're negative. And then grab one from out here, like +6. 6 plus 6 is positive, 6 minus 5 is positive, the product of two positive numbers is positive. So if we had never drawn that, just pretend you can't see it, it's gone, doesn't exist anymore. We would have drawn our sign diagram, we would have checked our representative numbers, find out if they're positive or negative y values there, and then ask yourself, which kind did I want? Less than 0? Those are negative numbers. Negative numbers are less than 0. You're not looking for negative x's. You're looking for where the y values are negative. This represents a function. So it could be written as y equals x squared plus x minus 30. And what we want to know is when are its y values less than 0, which means when are its y values negative. Our sign diagram says negative y values occur between this x and this x. There is no equal to bar, so this x and this x are not included. If you drop in x equals 5, you get a statement that says 0 is less than 0. That's not true. So we can't include 5, we can't include -6. Our answer set then is from -6 to +5, not inclusive. Oh, by the way, I already knew that was going to be the answer because of the graph theory. Once I knew the two critical values, I could have jumped immediately to this. This parabola points up. This is a horizontal line. And when you're below it, things are negative. Would you like to ask me a question about that? Any of it? It makes for good videos. Yes, ma'am.
So you want the numbers that are less than -6 and bigger than 5?
No, you
Or what's the
want y values that satisfy this condition, less than 0. This is what we were hunting for. When are this thing's y values going to be less than 0? Not seeing it, are you? It's okay.
like if you just saw -6, 5, how do you know what that means?
Well, because it's asking for a solution to an inequality, you know that this is not a coordinate. Because inequalities have spans of numbers that are solutions. So this isn't a single x comma y, especially when we were just solving for x. So it says begin at this x, end at this x.
So it's the numbers in between?
Every number in between these two x values will satisfy this condition. Like 4. If you plug in 4, 16 plus 4 is 20. 20 minus 30 is less than 0 because it's negative. So what's happening is this graph has negative y values between these two x values. And that's what we were looking for. And just to prove the point, x squared plus x minus 30. And y equals 0 is the x-axis. And you can see that this graph is below that horizontal line between those two x values, because that's what we wanted. Every y value between x equals negative 6 and x equals 5 is negative. And that's what we wanted, because those numbers are less than 0. Did you know Desmos could do this? And do dotted lines? But it's showing you specifically, oh, yeah, from here to here, it's going to satisfy. Yes?
Could you go back to the...
Yeah.
No, like,
Oh, the notes. Yes?
so if you were doing it without the equals and you had, like, the sign the whole time, you would get x is less than negative 6.
And that's why we got rid of the negative sign and treated it as an equal sign.
So you have to do that?
Yes. Because if you don't, you're going to get x is less than negative 6 and x is less than 5, which doesn't make any sense because those overlap in a weird way. They both point left. Because numbers to the left of negative 6 don't actually work. So anytime it's a polynomial, you have exponents. The moment you have exponents, you need to make a sign diagram. Or just understand the graph theory, but if that's running away from you, that's fine. Use a sign diagram every time.
You could always, like, go back and check it, right?
Of course you can.
The-
Yeah, so you knew that those were the values you were going to find, and then you were curious, so you checked your answer, and you go, okay, to the left of negative 6, you plug in negative 7, and then it fails. And you go, oh, something's wrong, you know, if you wanted to. We ready for what's on the back? Don't be scared. Someone said they're scared of what's on the back. So what makes this one different from the last one? It's not equal to 0. You cannot solve a quadratic unless it is equal to 0. So the first thing that we need to do is subtract 20 from both sides. And you know what, Emma B? What I just thought of? I said, you know what I just thought of? Let me grab a piece of scrap, and I think I can answer your question even better. Okay. We had x squared, what was it, plus x? Minus 30? And it said less than 0? What if it had said absolute value of? What if it had said absolute value of? You would have had to set up a positive case and a negative case, correct? We're not going to do that. But you know how when we set up the positive case and the negative case, one of them flips the sign over? That would have happened. It would have flipped the sign over eventually, but it's so much more work than is necessary. So that maybe does that answer it a little bit better?
Yeah.
Okay, yeah.
I feel like in advanced topics, we never would put the equals. We would leave it with the sign. If it was like that,
Yeah, but then it's wrong though.
always put it on the number line.
Yeah, I don't know.
Like the dots.
Yeah, what you're hunting for are critical values, and critical values are where it equals 0, and then you test your zones. But that's why. So if we had absolute value bars, we would have had to have checked for a positive case and a negative case. One of them would have flipped the sign over, and that's why we have to use the sign diagram. There we go. I think that's a better answer. Now that this equals 0, we can solve by factoring. I like the Lizzie method, so I'm going to do it that way. Looking for two numbers that will multiply to a times c. Our a times c is 2 times negative 20, negative 40. And we need that b value, which is what they add to be 3. Someone think they know which two numbers multiply to negative 40 and add to positive 3? 8 and negative 5. That'll work. Cool. Again, we're thinking equal to 0 because I'm hunting for critical values. So I am going to change. I'm not going to use this. I'm thinking critical values. So I have x plus 8 over, x minus 5 over, equal to 0. We need our a value here and here. X plus 4. And you know what? I'm going to leave it as x minus 5 halves. I'm aware that that's not properly factored, but it will still give us the same two critical values for x. The critical values are where your polynomial equals 0. So the two numbers we have to check are x equals negative 4 and x equals 5 over 2, which is 2.5, but I would leave it as a fraction on my test, so we'll just keep calling it 5 over 2. Again, this parabola points up, and what we're asking ourselves is, when is this parabola above y equals 0, above the x-axis? So if your parabola points up, and you're trying to figure out where it's above the x-axis, we're making the assumption that it hits twice. Wait, no we're not. We know it hits twice. Once there at x equals negative 4 and once there at x equals 5 halves. We're looking for when that parabola is above the x-axis. So that's going to be that way. And I put a bracket on purpose because equal to bar. And it's also above here. But just in case, I'm going to do the sign diagram. This is the kind of thing that when you have done these things forever, it's just faster than actually making the sign diagram. Remember, our sign diagram is representative of the x-axis. We found two numbers, negative 4 and positive 5 halves. We need to check our three zones. And we're trying to figure out, is it positive there or negative there? I'm trying to figure out what color I haven't used a whole lot of. Negative 5. Again, I don't care what the number actually is. I just want to know, is that going to be positive or negative? 5 plus 4 is positive. 5 minus 2.5 is positive. Multiplying two positive numbers, positive result. My favorite representative lands here. X equals 0.
Wait, wouldn't that be a negative?
What did I say? Wow, goodness.
It's negative 5 minus 5.
Yeah, it's two negatives, that's why. So it is. So negative 5 plus 4 is negative.
Yeah.
I think I said it was positive. Wow. I swear I'm smart. I really am. Anyway, dropping a negative 5 here does give you a negative number, and dropping a negative 5 here gives you another negative number. Multiplying two negatives gives you a positive result. 0 plus 4 is positive. 0 minus 5 halves is negative. The result of a positive and negative product is always going to be negative. And 5 over 2 is 2.5, so 3 sounds good. 3 plus 4 is positive. 3 minus 2.5 is positive. We were looking for numbers that were greater than 0. Greater than 0 means positive results. Our answer set then is where we have positive symbols. To the left of negative 4, including negative 4, because we did have the or equal to bar. That means all the way down to negative infinity. So negative infinity up to negative 4, including. Fancy U means union. Beginning and including 5 halves. And never stopping, going all the way out to positive infinity. We can't put brackets on infinities ever because infinity is not a number. It's an idea. It's a goal. You're never going to get there. So you can't bracket an idea. What do you think? Apart from me saying positive and negative wrong several times because Monday. How do we feel about the concept of the sign diagram? It is a big deal. Okay. The next one, then, is not a quadratic. But how do we typically solve polynomial equations? What's our go-to method, guys? Factoring. I know it doesn't say equals 0, but we're going to treat it as equals 0. In your factoring process, the very first thing you should always do is look for and pull GCF. This one has a GCF of x. Again, I set it equal to 0 because I'm hunting for critical values. Now we're factoring, looking for two numbers that multiply to positive 12 that add to negative 8. You can just say them. Okay, negative 6 and negative 2. This polynomial has 3 critical values. That means its graph hits the x-axis 3 times. I have a critical value at x equals 0 because there's an x on the outside. The moment there's an x on the outside like this, its answer is 0. I don't care if there's negative 3/7 sitting on the front of it. This x is outside, its answer is 0. Then we have x equals 2 and we have x equals 6. Our sign diagram this time has 3 critical values on it. So we have more zones to check. Picture not drawn to scale because who cares? It gave us 4 zones. Grab any negative number, it doesn't matter which one, to the left of 0. That's negative. How about negative 1? Negative 1 minus 2 is negative. Negative 1 minus 6 is negative. So I have 3 negative numbers being multiplied. What's that result in? Negative number. Boom. X equals 1 is in this zone, so let's try x equals 1. That's positive. 1 minus 2 is negative. 1 minus 6 is also negative. So I have 2 negative numbers this time and a positive. The 2 negatives will cancel each other out. X equals 3 works. Let's see. 3 is positive. 3 minus 2 is positive. 3 minus 6 is negative. I have a single negative number. And x equals 7 works. 7 is positive. 7 minus 2 is positive. 7 minus 6 is positive. Evaluate what kind of answers you were looking for. You were looking for answers that were less than or equal to 0. So what kind of solutions were we looking for? Let's see, I don't want to say solutions. We were looking for negative y values. So we were hunting for negative numbers. How about negative results? Here we go. Negative results. Oh. I have negative results to the left of 0. And that does have an equal to bar, so including. Then I have negative results between these 2 x values, including those 2 x values. There we go. Has anybody discovered or think they have discovered a shortcut? Maybe noticed a pattern or think you noticed a pattern? Yes? What's that? You can draw the graph for this one too. This graph happens to look like this. But have you noticed a pattern maybe? Yes?
The sections are never the same. They're opposite. They're always opposite.
It seems as though the sections are never the same and that they oscillate, right? That's what it seems like. Let's say it factored to this though. Everybody's packing up. Don't I still have 4 minutes? 10:09? Yeah? Okay. Just making sure. My x values are the same x values. Sign diagram, though, will be different this time. Because there's an x squared on the outside now, let's see what happens. If you drop a -1 out here, this is positive. And actually, this is always positive, so it's not going to affect our results. -1 minus 2 is negative. -1 minus 6 is negative. Those two negatives cancel each other out. Now, if you plug in x equals 1, 1 minus 2 is positive, 1 minus 6 is positive, and of course 1 squared is positive.
No, both the insides are negative, but it makes it positive.
Yeah. You said positive, positive.
You said positive.
Well, no, this positive like that.
Yeah.
Yep. Now, if x equals 3, that's positive, but this is negative. And if x is 7, positive, positive, positive. So if the question said this, and you were hunting for your negative results, this zone right here is your only zone that's correct. So you must always check the zones. Never assume it always oscillates. Cool beans? All right. I'm going to write it. Cool beans. How do you spell beans? Is it with an A or an E? No, it's not both. No, I meant like, is it EE or is it EA? It's EA, right? Stupid English language.